Today, a somewhat strange repair of a Polish telephone from the 1980s. Why weird? Hi, nice to see you on this channel. Every person collecting retro devices probably sooner or later faces the need to repair them. There are also repairs where not much needs to be done to bring the equipment back to the life, but figuring out what is causing the problems takes an enormous amount of time. And the case presented today belongs to this group. The Narcissus 270 stationary telephone has been produced in Poland probably since 1988 in a company called Telekom Phone Factory in Radom. For its time, it was a relatively modern design with a lot of additional features which, however, are not visible at first glance because to run them you had to select quite complex key combinations. The one that I got into my hands was supposed to be theoretically functional. It turned out, however, that it was not. Interestingly, it seems that someone delivered it to a repair shop which, not knowing how to fix it, broke it even more. There was also one issue more that didn't make the repair any easier. Well, I was not able to find on the internet the correct schematic diagram matching this particular copy. I only found a similar one. First of all, the design of the handset itself in my copy was completely different than the one shown in the diagram. It was more like the one from another phone from the same manufacturer called Pansy. Yes, this company liked to give their devices floral names. Secondly, in the middle of the schematic diagram you can see the mysterious KWI-275 keyboard module, the diagram of which, despite numerous efforts, I have not found. I only managed to get a datasheet of the UM91611 chip used in this module, where the manufacturer shows its application. Fortunately, as it turned out later, detailed information about this module was not needed. Finally, my copy differs in a few minor details, such as the lack of some jumpers of switches. The manufacturer mentioned it anyway, marking these elements on the diagram as depending on the version. Getting to the point, what was the patient suffering from? After connecting to the telephone network, only a soft hum was heard in the handset. No free or busy signal. However, after pressing the keys, with the receiver lifted of course, the device made quiet sounds characteristic of impulse dialing. Except the phone wasn't making any call. Attempts to call this phone were also unsuccessful. The ring didn't work, and you didn't hear anything when picking up the receiver. In a word, it didn't look good. Okay, it's time for surgery. The patient was first thoroughly scrubbed, but this is not shown in the video. You can see the phone cleaned previously. After opening the phone and handset casing, one issue was immediately visible. The cable from the Tonsil CBE76 dynamic microphone cartridge was broken. The repair took a while and it is not worth spending more time on it. The problem is that fixing this issue did not change the situation significantly. An investigation almost worthy of Sherlock Holmes has begun. What else might be wrong? So the video does not last many hours, I present it briefly. I also asked the guys for help on some internet forum about wired telephones. Together, we tried to figure out what the problem might be. And despite the long discussion, the phone was still silent. I looked at all the discrete components carefully to see if any of them were damaged at first glance. I measured the resistance of the resistors using a multimeter. It was okay. I also verified the rectifier diodes, Zener diodes and capacitors. The problem is that in order to be 100% sure of their correct functioning, they should be disordered from the board, and only then their operation could be verified. And this, for obvious reasons, I did not want to do. After such a check, I put a few elements on the list of suspects, but I decided to postpone their possible disordering. And as it turned out, it was a good decision, but more on that in a moment. I also disconnected the keyboard module and shorted pins 15 with 13 and also 16 with 11 to check if the keyboard module is not the cause of the problems. After this step, the phone should work properly, although of course dialing any number would not be possible. Unfortunately, the phone still didn't show any willingness to cooperate. So it was not a keyboard module causing the problems. But what then? The reason turned out to be very simple, as it sometimes happened with repairs. Well, the wires in the telephone plug were incorrectly connected. I discovered that the white one should be in place of the red one and vice versa. Simplifying, the red and green wires are for talking, while white and red ones are for the ringing signal. However, telephone exchanges uses only two lines, and most telephones with the same design have then two appropriate wires connected together. But it is not the case of this model. Here, the telephone simply does not use the white wire at all, so it is not connected to the central office. This is due to the specific design of the device. Returning to the merits, it turned out that the change of wires gave life to this device. Do you admit that it is a bit surprising solution? But that's not the end of the story yet. The phone started working, but the bell still didn't ring. Depending on the position of the min-max switch, it was either completely silent or made barely audible noises. Let's take a look at the device diagram for a moment. Why is it possible to combine the functions of two lines within one wire? Well, the whole secret is hidden in the C1 capacitor. When the telephone exchange supplies only direct current, this capacitor acts as a kind of impassable barrier. However, when someone calls us, the telephone exchange adds an alternating component to the direct current, and then we can say that the barrier made of the capacitor C1 disappears and the alternating current flows straight to the buzzer. Yes, the telephone uses a piezoelectric buzzer, a cheap but completely sufficient solution for this type of devices. As can be seen from the diagram, it is connected to the alternating current drawn from the telephone line via a diode which cuts off half of the waveform, and there is no any additional filter capacitor. Thanks to this, a sound with quite characteristic modulation is generated. In fact, it should be, because the buzzer was silent. The buzzer has probably its own 4 kHz generator, which is additionally modulated by the frequency of the telephone line 25 Hz or possibly 50 Hz, which results in an interesting chirp sound. We will listen to it at the end of the video. Most buzzers have polarity and therefore need to be connected properly, plus to plus and minus to minus. What's worse, most of them do not have any protection against reverse connection, and in such a situation they are damaged. I was wondering if it was possible that the buzzer was connected the other way around, but fearing to damage it, and analyzed what else could be the cause of the problems before I decided to change the buzzer connection. And again a little miracle. The phone began to ring. Why did someone who serviced this device connected the piezoelectric buzzer to the other way around? I have no idea. Fortunately, the buzzer was not damaged. Tough beast. Satisfied with the result of the work, I quickly assembled the phone and declared the victory. However, it turned out quickly that it was only a partial success. Well, after connecting the phone, I noticed that pressing some keys causes that a given digit was dialed twice, not always but very often, and sometimes even 3 times, very rarely. I will add that when cleaning the phone, I chose not to open the keyboard itself, assuming that assembling it may not be trivial, but apparently someone else was disassembling it before me. The chip responsible for the keyboard itself contains a module that protects against vibration of the keyboard contacts. However, as the description shows, it is a protection against very short vibration, so something still had to be wrong. I decided to open the phone casing again, and this time to disassemble the keyboard. As you can see, the design of the keyboard is very interesting and multi-layered. The brass plate stiffens the whole structure. Spring contacts being part of the steel plate, I used to short-circuit the appropriate fields on the printed circuit board. We also have several insulating layers. What is the reason to apply such a complex multi-layer structure? I am not sure about that. First, I suppose they wanted to ensure many years of reliable operation, as evidenced by, for example, the way of producing the keys, as the symbols of the numbers are not printed and the keys themselves are made of the 2 different casing of plastic, and thus the number do not wear out, and they will probably look just as good as now in several dozen years. The second reason could be a way of working with the aforementioned UM91611 keyboard chip in order to provide, figuratively speaking, a sufficiently clear signal and possibly also to limit contacts vibration. Finally, they definitely wanted to provide insulation from the outside environment so that dirt and dust would not get inside. The keyboard has been cleaned and assembled. Unfortunately, it turned out that this procedure only worsened its functioning. More keys began to suffer from the syndrome of dialing the same number twice. Why? Looking for help on the internet did not finish with success. At first, I assumed that simply the age of the keyboard and the fatigue of the material mattered. The solution turned out to be very simple. Well, it is enough to slightly bend the plates and to pay attention to one small detail when assembling the layers. The tips of the steel keyboard contacts must be properly inserted between the other layers. If not, the contacts are not working properly. After reassembling, finally success. The keyboard started working perfectly, fully perfectly. By the way, I discovered while browsing the photos of this device in the internet that the manufacturer had provided an elegant socket to mount the buzzer. Earlier, a crazy service technician put it in the wrong place, and I repeated his mistake at the beginning. Now it was time to celebrate the end of the repair. What do you think about such a repair? Apparently not a lot of work, but it took me an incredibly long time to figure out the cause of the problems. Finally, there were as many as 4 defects to be removed. You can clearly see that the phone was previously given to some crazy service technician. Fortunately, the phone is back among the living. If you made it to this point of the video, please be sure to write as the comment. I am a retro tough guy. I love retro repairs. Would you like to know more about how this phone works and what its features are? Stay healthy.